Welcome to this UASMaster video tutorial. In this video we want to take a look at the analysis functions from UASMaster. You should have finished already in previous video tutorials the automatic tie point extraction, the control point measurement, and the extensive adjustment with camera calibration. When the extensive adjustment succeeded, we want now here start this video tutorial with creating the report file from the UAS tab. So here on the right side, go to Report and press Create Report. After the report was created, we want to take a look at the report. The processing report is a great way to check the geometrical accuracy, to check with graphics the connectivity, and also the uncertainty in the block. At the beginning we have an overview of our project, giving us image informations, projection coordinate system. Then in the flight overview we can see which cameras have been used for the adjustment and which camera or which exterior orientations from the photos have been eliminated. The green ones locate the ones that are used. The red ones would show us eliminated photos in our adjustment. Then in the tie point distribution we can check now the connectivity of the photos. The colorization code is here written down. Points that are only measured in 1 or 2 photos are red. Points that are yellow, they are existing in 3 or 4 images. Points on top in the graphic which are green are typically what we expect for UAV projects. So we should have a lot of green points and yellow ones, and blue ones mean they are in more than 10, which is a very strong connectivity. So in our case, of course, in the center where the most overlap exists, we expect to have the blue ones. We expect to have green and yellow ones covering the complete project, and the red one should just be at the border. If we have red points in the center, then there should be also around the red ones yellow and green ones. So if we would have just like here in the bottom a red area in the center somewhere, then this would be suspicious, and then we would need to check perhaps closer in the UAS measurement where this location is, and perhaps this is here not so well connected. Then in the camera calibration, this is now our accurate model from the camera, giving us a new focal length for the camera and also new, in this case, distortion values. So this is our new focal length in pixels, or here in this case in millimeter. So 15.3952 is now our accurate focal length for this camera and this project, and these are the distortion values. Additionally, also we have then the image residuals for the camera itself. Typically we should see no systematic effects. It should be like a more noisy image, having here values that are going into all different locations. If all our distortions would point in one direction, or if we would see some circular shapes or some patch shapes, then this would indicate that something is wrong with our camera sensor. Then we have the block adjustment informations. So here we see what was used for our adjustment, how is our sigma naught value. Then also we have here standard deviations for the translation and rotation, and here our standard deviations for the ground control points, which are around 1 to 2 centimeters in position and 5 centimeter in height. Next we will have the exterior orientation statistics. So here we can see now that our average, this standard deviation for the projection centers is around 2 centimeters. So our uncertainty is here around 2 centimeters in position, and we have here about less than 1 centimeter in height as a standard deviation for our projection centers. We see also some max values, which are here 4 cm and 1 cm for these projects. With these standard deviations, we can also typically see that at the edge and the border of our block, the standard deviations are larger than in the center, which should always be the case. So if it would be different if we would have here in the center our largest standard deviation, then this would be suspicious, because we have here a lot of connections. Remember, 10 or more connections in the center. This should normally cause a good standard deviation, so the uncertainty should be very low in the center, and therefore this should not surprise us. Finally, we have the ground control points, where we have the errors. So this is then the given coordinate minus the measured coordinate, showing us for each single control point in X, Y, and Z. And of course we also have then the ground control point residuals, and these residuals here are then shown in a graphical way. And be aware, this is now here a relative size. They look very large, but if we look here at our average values, then we talk here about 1 or 2 centimeters in X, Y. And finally, at the end, the standard deviations for our ground control points. So how well could they have been positioned in their location? And again, here, this should not surprise us. This should be similar like our photo observations or our images. And they are here also in a very small range below 1 centimeter for it. Please store this PDF on your hard disk. This is for documentation and also for further processing important that you know your accuracies for your project. Or also in case you want to contact support from us, please always attach this document to it. Additionally to this PDF, we also have here in the UAS measurement, in the properties, many options to show the standard deviations, to have individual looks here at the different block in different areas where we can show these values, and this is then shown in our training, which is offered for UASMaster. So if you are interested into an in-depth analysis, then please contact sales from us, where we will go here in detail to all the different functionalities. The tools allow us to make checks for the connectivity, the joint parts, for each photo, how they are part of the block. And even then, when we have difficult areas, we can look even at the point statistics and have here analysis tools. The bidding cells allow us for very large projects to have a very easy and good way to detect difficult areas. After a successful adjustment, all your camera locations should be used for the adjustment, so there should be no eliminated camera locations. You should have standard deviations for your camera locations which are within the range that you want to achieve. No ground control point should be eliminated. All your ground control points should be within a standard deviation that you assume for this project. The camera calibration should be successfully calculated, and we should see no systematic effects in your camera. As mentioned, a more in-depth explanation for the analysis of blocks is given in our UASMaster online trainings, which you can order through our sales team. In our case here, we are satisfied with the result and save the project. And then in the next video we will cover the automatic terrain extraction and editing. So thank you very much for watching this video tutorial and see you soon. Bye!